Welcome to this fourth video in my Django plus HTMX series. Today we'll see an alternative and probably better way to integrate the Django messages framework with HTMX. In the previous video, I showed you how to do that with the HX trigger header and some JavaScript code. This time, I'll use out-of-band swaps to inject the toast into the DOM. Let me remind you how the previous version worked. So here is a button on the screen with the HX get attribute. When the user clicks on that button, HTMX performs a get request, which triggers the execution of a Django view. The view creates an HTTP response and publishes one or more messages. The response is intercepted by our middleware. The middleware pulls the message and stores them in the HX trigger header of the response. The response goes over the wire and is received by HTMX. HTMX updates the page with the response body. When it sees the HX trigger header, it calls a JavaScript function. This function creates the toast and adds them to the DOM. Finally, the browser displays the toast along with the updated page. Now, let's see how the new version works. Everything before the middleware stays the same. The middleware still pulls the messages, but instead of storing them in the HX trigger header, it appends the toast divs to the response body. The response goes over the wire and is received by HTMX. HTMX updates the page and injects the toast divs into the DOM. Finally, the browser displays the toast along with the updated page. As you see, we don't need much JavaScript with this new version because we piggybacked the toast to the page. This is what HTMX calls out-of-band swaps. They are out of band because they are not part of the primary swap. Instead, they target specific elements of the DOM. This technique is more in line with HTMX's philosophy of rendering the HTML in the backend. In this graphic, I try to represent the primary swap and the out-of-band swap. The primary swap targets the element designated by the HX target attribute or the element that triggered the request if HX target is not set. The out-of-band swap includes all the elements with the HX swap OOB attribute and targets the element with the same ID. Let's open the code from the previous video and see how we can upgrade it to use out-of-band swaps. Here is our button. As you can see, it has the HX get attribute, which tells HTMX to perform a GET request when someone clicks on it. However, it doesn't have the HX target attribute, so the button itself will be the target of the primary swap. This was okay for the previous video because I intentionally skipped the primary swap, but I prefer that you see the effect of the primary swap now. I don't want to swap out the button, so we must add the HX target attribute. For example, let's add HX target equals ID main to the button. And let's say that this paragraph has the ID main. This way, the primary swap will replace the content of this paragraph and leave the button unchanged. Here is our view. As you can see, I used the status code 204 to skip the primary swap. As I said, I don't want to skip the primary swap, so let's change that and instead return a paragraph with a random text. Of course, we need to create this template. In this case, I'll simply use the built-in template tag lorem with the random argument. Let's check that this works. Indeed, clicking the button replaces the paragraph with random text, and the toasts are still working. Now, let's update the middleware. As you can see, it currently uses the hxTrigger header to forward the messages to the front end. Let's remove all of that. Instead, we'll include the toast in the response body. We can append text to the response with response.write. And we can use render_to_string to render the template. This function comes from Django template loader. Of course, we must include the messages in the context. Finally, we can get rid of import JSON. Let's see the toasts template. Here you can see that we have a loop that goes through each message to create a toast. That's exactly what we need. And here at the top, we have a div with the data toast template attribute. We used this as a template to create a new toast in JavaScript. We don't need it anymore. We can also remove the data toast container and the data toast body attributes. Now we need to add the hxSwap_OOB attribute. Since we want the new toast to appear on top, we must use the value after begins. This tells HTMX to insert the content of this div after the beginning of the div that is currently in the DOM. Of course, HTMX needs to know which div we are talking about, so we need to add an ID. Now let's see the JavaScript code. Here you can see the function that HTMX called after seeing the hxTrigger header. Here you can see the gymnastic to create a toast from the template. We can get rid of all this code. Does this mean we don't need any JavaScript? Unfortunately, not if you use Bootstrap, because the toasts are initially hidden. To make them visible, you must create an instance of the bootstrap.toast class as we used to. Let me undo and remove only this part. Here you can see a loop that goes through all the elements with the toast class to construct a bootstrap.toast instance. We can, of course, get rid of the CSS selector that we use to keep the template hidden. Now, the problem with this code is that it's only executed when the page loads, so it cannot show the toasts included in the out-of-band swap. We need to tell HTMX to call this piece of code every time it updates the page. We can do that with htmx.onload. HTMX will call this function on the initial page load and any subsequent partial page load, including OOB swaps. Now, we probably don't want to create a new toast instance for the toasts that are already on screen. In theory, I could use the element passed to the onload callback to only target the new toast. But in practice, I could not find an elegant way to do that. So instead, I suggest we call bootstrap.toast.getInstance to get the toast class instance attached to a div and only create a new one if it returns null. If you look at the code on the GitHub repository, you will see that I also discard all toast so that we don't end up with dozens of useless elements in the DOM. Let's check that everything works in the browser. Don't forget to hold the Shift key when you click refresh so the browser performs a hard refresh. Indeed, if you do a regular refresh, the browser will probably use a cached version of the JavaScript file. As you can see, everything works as expected. The primary swap replaces the paragraph with random text, and the out-of-band swap inserts the toast. There you go. Toast messages with HTMX out-of-band swaps. Honestly, I still haven't fully made my mind. Is this technique superior to the one using hxtrigger? Sure, it seems better since we removed the clumsy JavaScript. However, we carelessly appended content to the response body. Can we really do this every time? To tell you the truth, I'm still using the old technique on my projects and I'm not ready to switch yet. Anyway, let me know what you think in the comments. Oh, one last thing. If you use my empty response technique to close modal dialogues, don't forget to change the status code from 204 to 200, otherwise the OOB swaps won't happen. Okay, that's all for today. See you in a future video.